We're going to take a look now at an example where we are going to graph a cosecant function, and then in the next video we'll graph a secant function. So just reviewing some key features of these and what we're going to look for in order to graph these. First off, we're going to graph the reciprocal function. So when we're looking to graph a cosecant function, we're going to first graph the sine version of that. When we want to graph a secant function, first we're going to graph its cosine partner. Then what we're going to do is any x-intercepts on our sine or cosine, depending on what we're using, those are going to change into our vertical asymptotes on cosecant and secant. And then any maximum points on our sine cosine graphs are going to be the minimum points on the cosecant secant for those parabola-like shapes, and then any minimum points on sine cosine are going to become our maximum points on the downward facing U-shapes, parabola shapes, if you will. So in this example here, our mission is to graph y equals the cosecant of x plus pi over 4. And in order to do that, we need to graph y equals the sine of x plus pi over 4. So this is going to be where most of our work is in graphing this here. So y is equal to the sine of x plus pi over 4. Let's identify. A is 1, B is 1, and then C is pi over 4. A is 1, B is 1, they're not there, remember the invisible ones, and then C for finding our phase shift is pi over 4. So A, 1, this says that our amplitude, I'm going to abbreviate it, is 1. B, we use that for the period. Period is 2 pi over B, which is 2 pi over 1, which is 2 pi. So here, our period's going to be 2 pi. We did not change anything up. And then our phase shift, so you know by now I abbreviated PS, phase shift is C over B, which is in our case pi over 4 over 1, which is pi over 4. So our phase shift is pi over 4, and being that it is positive, this means that we're going to be moving, we're going to be shifting to the left. So we're moving towards the left. So now, to graph these, we need 5 key values. So first key value is always our beginning value. If we have no phase shift, it would be 0. But in this case, we do have a phase shift of pi over 4 to the left. So our first x value is going to be negative pi over 4 because we shifted back to the left. Now, in order to generate our other 4 key values, we're going to take our period, which is 2 pi, and we're going to divide it by 4. So 2 pi divided by 4 is pi over 2. So we're going to be adding an increment of pi over 2 to every angle to generate all the next 4 key values. So when I look at this pi over 2, so here I know I need to add pi over 2 to negative pi over 4. So that whole pain in the neck addition with fractions, the denominators need to be the same. So what I'm going to say here, instead of using an increment of pi over 2, let's look at pi over 4. So this is what we're going to use. 2 pi over 4. 2 pi over 4 is the same as pi over 2, but in this form we're going to be able to do our addition to our angles much faster. So here, you know what, I'm going to switch to pen because I think the marker is going to be too much to stuff in here. So this next angle here is going to be pi over 4 plus our increment of 2 pi over 4, which gives us a positive pi over 4. So Next, we have pi over 4, because we always start with this angle. And some of the homework, I saw some funky things going on there. And then we add our increment of 2 pi over 4 to get 3 pi over 4. So I think you can see the pattern here. Pi over 4, 3 pi over 4. Dare we guess the next one will be 5 pi over 4, but let's take a look. 3 pi over 4 plus 2 pi over 4 does indeed give us our 5 pi over 4, and then this would be 7 pi over 4. 5 plus 2 is 7 pi over 4. So here are our 5 key x angles, the angle measurements. Now, in terms of our sine, we can fill these in because we know this represents our starting point, which normally would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the corresponding sine values of those would be 0, 1, 0, -1, and 0. And since we do not have a change to the amplitude or reflection, these are the y values that we are going to use in our graph. So in this particular example, I've started the graph work here for us, so as to not get too bogged down in it. But we can see here is our sine function that we just generated the values for. At negative pi over 4, we're at 0. At positive pi over 4, here we're at 1. At 3 pi over 4, we're back at 0. At 5 pi over 4, we're at -1. And then at 7 pi over 4, we are at 0 again. So here is our sine function. And let me label this. This is y is equal to the sine of x plus pi over 4. So there's our sine function. What we want now is we want to generate the cosecant function. So every place that we have a 0 value here, we're going to have a vertical asymptote. These aren't terribly straight, but I don't want to take the time to haul out the ruler. So here we have vertical asymptotes. Sine is 0, cosecant, vertical asymptote. The other thing we have, at this maximum here for our sine, this is going to give us a minimum for our cosecant. So here we have half of it. I mean, technically it would continue like this, or I stopped the sine function, but it would look like that. And then where we have a minimum for our sine, this now becomes a maximum for our cosecant function. So this here is cosecant of x plus pi over 4. So there's our first example.